Okay, you can see the presentation now,
Yes.
Mr. Jibber?
Can see.
Okay, we can start. Today we will speak about one step toward predicting the PV station energy production. First, we have an agenda to do this. I will speak about my bio. Then we can speak about the PV penetration and the power management challenges. Technical explanation about the topic we will speak about. Then solution impact. And at the end, we will speak about the conclusion, and I'll show you the code and the web application that I developed. Let's go. At the beginning, I have a baccalaureate degree at electrical engineer from 2016. I worked as electrical power engineer. At first, I worked for Modica for textile, which is textile factory. Then I transferred to work at Solatech Systems for PV installation. Then work for leader for renewable energy, and now I work for Nomad. Now I prepare my master degree at power electronics at ABERC, which is one of famous research center in this field. We'll speak about PV penetration and its challenges. First, everyone can hear me clearly, or?
Yes, all is well.
Okay. We'll speak about the PV station working principle, how it can work, how it can export energy to the national grid. First, PV station have PV panels that can convert sunlight into DC electricity. And by means of inverter and transformer, we can tie to the national grid and export this energy to the national grid. This technology is very good and have a lot of advantage. It is free of noise. It is renewable. Have a lot of advantage which make it so popular now. And all countries all over the world have a plan to transfer to depend on it in their national grid. But it have some issues if we depend it on the national grid. The biggest issue of the PV penetration in any national grid is to know definitely the ability of these stations to contribute in your overall production, because this is most important issue if you want to make power management, which is an important issue facing those people who work for grid stability and like this. Okay. Now we can do this by means of machine learning techniques. We can develop techniques that can predict how much power this station can produce and how this PV station can contribute in the national grid. These models can be based on forecasted weather, forecasted irradiance, and take their information from satellites. Okay, we'll speak about our data set. First, our data set have 5 features or 5 columns. First, irradiance, which is one of our predictors. Our predictors, Mr. Gilbert, is those values or variables that I'll base on them to build my module or my model to predict the production. Okay, I have two features. I will base on them to build this model. First is the irradiance, and the second is the temperature. Model temperature is so hard to predict. I know that it have a mathematical relation with the temperature, but in this at this time we can speak about data duplication, which we want we don't know need to use. Okay, so those two variables or two features related to each other is the overall temperature or the temperature of the air around the PV station or the PV module raise, its temperature will raise also according to its loading, its current. Okay. Other feature is active energy. This isn't the feature that I will predict because this feature is accumulated energy, which means when this energy produced at this minute, other one is this energy, this amount of energy which is produced, plus the amount of energy produced at the second minute, which so these values are accumulated on each other. Here we have the net energy exported to the national grid. Okay, we will speak about the pre-processing which we use. At the last, Mr. Gilbert, we will speak about the code, but now we speak about the pre-processing and some process we deal with to predict our model. Okay. First, I rename the features because, as you know, when we export these features from SCADA system, it have coding names or labels. Okay, Mr. Gilbert. Hello?
Yes, I'm listening. Putting on mute because I have some noise.
Okay, this noise must anyone have noise also?
No, when I am here, see, you cannot hear the. Sometimes I generate noise because I have servers beside me.
Ah, okay. Okay.
No, but I'm listening. I'm looking at it.
Okay. First, I rename the features. Then we merge the data. I have 60 CSV files. So I merge all the data from these 60 CSV files in one Excel file, which have now 22,662 feature or record or measurement with 5 features. Then we calculate the net exported energy as I showed before. This value I export depending on the active energy. Then we drop 0 energy records, which come at the early morning or at the night. As we know, PV stations won't produce energy at morning or at night. We will speak about model and evaluation. I test a lot of models, but at the end, first I test support vector regressor with RPF kernel, which gave me so bad score for test and training. Then I test support vector regressor, but with linear kernel, also give very bad score. At the end, I use multiple linear. It gives somehow good score for test and training, but it isn't the optimal one. So at the end, I use polynomial regressor, which gave me 96.7% test score and 96.73% for train score. Now we can go to the code. Okay, this is the code. We build this code as a web application. Okay, so this is the HTML web page. Okay. Also, to tell you, Mr. Gilbert, this data I upload on a server, not real server, but it is virtual server, which is called Larajon.
Yes.
Okay. We can deal with this like real server with user.
Yeah, I know, it's a virtual machine.
Yes. Okay. So this is
I have two at home.
Yes. Because you know, if we want to use a real server, we will pay money. So we don't need this now. Okay. I need to copy. We can. This is our data. This is the date and the time, radiance, temperature, module, energy, and net energy. This is the server that my model will use to export the data or import the data from. Okay, we will go to run the model. It will take some time. I choose the title as a step toward predicting the energy of station because this isn't the final value. I find that radiance, we can build a separate model to predict the irradiance according to environmental condition or weather conditions or time series or neural network. According to a lot of principle, we can predict irradiance because if we go to any site that forecast weather conditions, it won't give us forecasted irradiance data. This is the model. Okay. We trained it before, so it's successful. It trained successfully before. Okay. The evaluation of this training is like what you see. Train accuracy is 96 and test accuracy is 96 also with root mean square error like what you see. We will go to prediction. This is the place which I can use to import my data to predict the production. Let's say this. Let's say 40. Let's say okay. This is the power related to this temperature and this irradiance. Okay, 20 megawatt. As I tell you, this isn't the final step. It is the first step toward building a complete regression model. Okay, if we need to build a complete regression model, we can build a separate model for predicting the irradiance and separate one for predicting a lot of features that we can depend on to predict the power production. I need to show you some sites I will use later to predict this. I think dark sky. This can give us a prediction or forecast for the temperature for I think 10 days forward. Okay, that's it. If anyone have any question.
So, how many days do you use for training?
It is only 1 month's data because I have a limited time to build this model. So I take it as a first step for me to build this. But if you want it to be accurate, we can use data for 1 year. We can use another model or another technique like time series, like neural network, which will give us accurate data. But now, because I have a limited time, I use this technique, which is traditional regression technique. Okay. So I would like to thank you all. Thank you, Machinify team, our instructor. Okay. For me, it is enough. If anyone need to add anything, Mr. Gilbert or Mr. Said.
Well, I will see that well, you are putting a lot of efforts on machine learning, but I will also encourage you to use the traditional equations. So there is a lot of equations that you can use
I know.
to tune the model. So you can train the model with equations, and then it will make the so. Try to look for something called a model-based prediction and Kalman filters. I believe we should. It's a good problem for that type of.
I know there now they developed some equations that can predict this, but I take this as a challenge for me as a first step in this field. And as I tell you, this isn't the total work. This isn't it isn't a total work. It needs a lot of development, a lot of optimization. We can build a model to predict the irradiance, which I think doesn't have any equation to predict it until now. We can build a model to predict a lot of features that affect the operation and production of the station. But as a step, I think it was a beginning for me.
It's an excellent. It's an excellent.
Okay, thank you.
Thing. I only giving you some idea for future development.
Okay, I will be pleased to share this idea with me.
Okay, thanks. Thank you for inviting me.
Thank you for your time. Thank you all for your time.